Hi everybody, this is Charles IOHK, and I wanted to give you guys a quick Hoskinson, Chief Executive Officer of IOHK, of July update on Cardano and a couple of housekeeping items. First, happy 4th of July. I think it was over 240 years ago, 242 I think, the United States began. A bunch of rebels decided to go do something crazy, and it worked out pretty well, I think. Anyway, so a few things about what's coming up for Cardano. Cardano 1.3 is right now in QA. We've already passed the first QA cycle, and if we keep with this current rate and we don't detect any major problems during QA and all of the integration testing, we should be looking at an early August update for both Daedalus and for Cardano. This particular version of Cardano carries with it a lot of network enhancements and a lot of code refactoring. There's also some enhancements to Daedalus itself. We've considerably refined some of the underlying code and memory utilization, so we're looking at probably a factor of 5 or 6x reduction in memory usage. Our internal benchmarks went from 1.2 gigabytes to about 200 megabytes on the Mac client, and a litany of other little things. So look for that. That's pretty exciting. We have some new wallet news. We've been working in a joint partnership with another company, and come August 15th, there's going to be an announcement that I think everybody's going to be very excited about. And this wallet's quite complementary to Daedalus, and it's going to have a lot of cool and interesting features and a pretty nice roadmap. So look for that in mid-August. Coming out in late July, right now we are on target to release the Yella Testnet. And this is really exciting because this is the first time you're going to be able to write smart contracts using something other than the EVM. So you'll be able to use Solidity or Yella code itself. We've added support for Yella in Remix, and there's going to be a lot of really cool custom assets that are coming out this month with respect to that launch. And we're going to also shoot some videos and tutorials and other things. And our hope is that you guys can start using the Yella testnet and letting us know what you think. The KEVM testnet launch has been very successful. We've already gotten a lot of really great advice about some changes we could make to make it a bit more developer friendly. We've also hired a new smart contracts product manager. His name is Mark. He just recently joined the team, and he's going to be thinking a lot about developer experience and things like SDKs and frameworks and these types of things to make Cardano the best platform in the space to develop on. So that's coming out soon, sometime this month, unless something slips. But right now it's on schedule. We're pretty happy about that. We're also making a surge on the QA side, and our hope is to automate a lot of things we're right now doing manually. We're working with two firms on that. One's called Allied Testing, and the other's called Cuvic. We've learned quite a bit from them, and throughout the summer it's going to be a big priority to automate as many things as possible. So that's quite a bit of fun. Moving beyond August and moving into September and October, we're going to have Cardano 1.4 on the horizon. Now, 1.4 is probably one of the largest updates to Cardano since we started doing updates. And this is going to include the Cardano wallet backend that we've been working on really since February or so. So back in February, we'd learned enough at that point about how UTXO-style wallets work to go ahead and write a completely new specification and then rigorously prove a lot of interesting properties about that. So you may have recently noticed a blog post that we launched that Edsco van Ries, one of the well-typed computational logicians, wrote as a guest blog, and basically it explains how we do input selection. That and dozens of other things are a direct result of that project we started in February. Well, right around April is when the specification finished, and we moved into the implementation side of the specification. So we have 6 engineers working really, really hard, really long hours, and we think that sometime in September we'll be able to cut that to dev branch. And then at that point we'll start the QA process, and however long that cycle takes, it'll get released as Cardano 1.4. In addition to that, we have a whole team of people working on the core of Cardano and doing a boatload of refactoring, making it a heck of a lot more modular and easier to write tests against, and also preparing a lot of the infrastructure work for putting in all the Shelley-specific code, which is for decentralization. So that team has probably another 4 to 6 weeks of refactoring work to do, and then we're in a pretty good position to start building things and really enhancing the test coverage of core and increasing the reliability of things. So a lot of that work will end up in 1.4 as well, and we're pretty excited to see that. 1.4 for the everyday user probably won't see significant speed ups or performance enhancements. Where it's really going to be useful is for exchanges who are operating at scale, and they have lots and lots and lots and lots of addresses they manage and lots of transactions in and out. And with those class of users, we feel that 1.4 is going to be great for them. In addition, we're gradually moving Daedalus over to the V1 APIs that were released in Cardano 1.2. There are 19 of them that are currently specified. Daedalus actually uses 26 APIs total, and we're starting the process to gradually connect to those APIs. And then we're trying to decide whether to extend the V1 API to cover all of Daedalus or to use a different method for that. So there's a little bit of debate, but we'll have that resolved pretty soon. Anyway, the V1 APIs are very good, and if you're an exchange or somebody building something on top of Cardano, highly recommend you look at them. They're much better than our first attempt at doing these things, the V0 APIs. In terms of specification work, sometime this month, the delegation specification should be finished. And then at that point, it's going to be sent over to the guys to implement. We also have the incentives work stream conceptually done, so we have a really good idea of what we want the first version of Shelley's incentives to look like. We're still having a lot of questions about what do we want to do on the network side of things. We're still in deep design with that, but we have some pretty good concepts that we're slowly pulling in so that we can get everything we need for Ouroboros and for decentralization. We also are gradually scaling up the team that's working on Ouroboros Genesis, and that team is going to start thinking carefully about what a prototype looks like. And it would be really nice, in addition to implementing it into Cardano, to also create a standalone prototype for people to use in other projects. We've also had some discussions with a pretty diverse group of people who are interested in Ouroboros. Most prominent of which is some members of the Hyperledger group who are curious about what Ouroboros could do for projects like Fabric. So we're kind of trying to figure out if it makes sense for them and it makes sense for us, and so forth. But it's a pretty nice protocol, and a lot of people seem to like it. It unfortunately is a bit hard to explain, and it's right now living in the world of cryptographers and high science. And what we need to do is kind of pull that into the engineering world and make it far more understandable. The benchmark in terms of pedagogy with that respect is a protocol called Raft, which was created by Diego Ongaro and John Osterhout over in Stanford. And the purpose of Raft was to be a protocol that does everything Paxos does, but is much easier to explain to people. So we're looking at Raft very carefully as an example of how to explain these types of protocols, and our hope is to apply those same types of techniques to Ouroboros, so it's a bit easier to understand how Ouroboros works under the hood and how it solves certain classes of problems endemic to proof of stake, such as long-range attacks and nothing at stake and grinding attacks and so forth. So look for that on the horizon, and that's going to be a big project for IOHK research. Okay, after Cardano 1.4, we've also really started scaling up the Plutus development and the Marlowe development. So that team has gone from 2 people, one of which only worked half-time, now to about 6 people, and our hope is to scale that to 8 people. And the design of Plutus is actually starting to stabilize. And so we're now starting to have discussions about Plutus as a smart contracting language and how Plutus is going to interact with the outside world and how to embed it in things like Haskell and so forth. So throughout the summer and fall, that team is going to be working really, really hard, and our hope is we can pull Marlowe and Plutus into Cardano as soon as we can and combine it also with our chimeric asset standard that we've developed for issuing assets in Cardano, so we can make it a multi-token ledger as opposed to a mono-token ledger at the moment. So we'll do some dedicated content for that. Hard to say exactly when that'll come out because we're still kind of debating a few things about final things on the design, but the good news is that team has grown considerably, and it's filled with some very remarkable people, from Phil Wadler to others, and look for some of those achievements soon. I really like Manuel Chavardi. He's easy to work with. Okay, so that's the Plutus side of things. Yella's coming along really well. The KEVM is coming along really well. We're also seeing some great progress with the rewrite of K itself. It's being rewritten in Haskell. And we're also seeing some great progress with semantics-based compilation. and we're starting to test SBC concepts with functional languages, not imperative language, not just imperative languages. I actually went over to Urbana-Champaign, which is a town with basically a university wrapped around cornfields. It's a very small town, but with a gigantic university. And I spent a whole week with the runtime verification team taking a look at some of their demos, and we were actually able to run an ERC20 token on Yella, and we had a lot of conversations about where SBC is going, and the results there are quite encouraging, and it was kind of a high-risk, high-return project. So it's nice to see that that's actually moving along quite well. Anyway, throughout the year, we're going to keep hammering that and really trying hard to push the envelope and get things done. A few housekeeping items. I occasionally get asked questions on Twitter, and one question I got asked by a user called Below Searcher, who asked if we're ever going to publicize the peer review content that we get when we submit papers to conferences. And I felt, well, this question deserves an answer, and it deserves an answer that's greater than 140 characters. So for those who aren't familiar with the peer review process in the computer science world, generally you submit papers to conferences, and there's different tiers of conferences. So for example, in the cryptography world, there's crypto and Eurocrypt and so forth. And then there's tier 2 conferences like Financial Crypto and Asia Crypt and so forth. And then you have tier 3 conferences, which tend to be a bit more easy to get into, and also meant for papers that aren't quite ready for prime time but very promising. Anyway, the top tier conferences, the acceptance rate of papers that survive peer reviews is roughly about 10 to 15%, sometimes up to 20, but not really a lot. And they get a lot of papers from very prestigious researchers at very prestigious institutions like Cornell and MIT and Harvard and Oxford and so forth. So how that process works is that you actually submit the paper blind, and the reviewers are blind. So it's a double-blind side. They don't know who wrote the paper, and you don't know who's reviewing the paper. But you know that the reviewers are selected from a review committee associated with the conference. So you can kind of guess what subset is looking at it. And those reviewers have a lot of options, from strongly accept to strongly reject. And then there's a spectrum of decisions in between. So they'll write some comments up and make an initial decision, and then you're given a rebuttal. Then you can write the rebuttal. Then they can either change their mind, but it can usually get another reviewer as well. And then they'll decide from the collection of papers that have been reviewed which ones are worth being presented at the conference. So those comments and that back and forth, however long it takes, are generally not publicized because this gives the reviewers and the paper authors freedom to be a bit more honest and a bit less diplomatic in the way that they present things. Whereas if those things were public, they would actually have to be a bit more conservative with what they say and how they present things and so forth. That said, the conferences themselves are public affairs for all those who register, and the presentations are public, and the dialogue there is public. So that's kind of a fair compromise between what's necessary to get honest, good dialogue and what's necessary for transparency to the academic community. So, for example, we presented Ouroboros Genesis and Prouse at Eurocrypt, and there was quite lively discussion at Eurocrypt, whereas the peer review process for it is generally considered to be private. And that's just the standard for the entire space, and that's a standard for the academic community as a whole. So we will not be publishing those comments. It would be counterproductive, and I think there is a great degree of wisdom in keeping them within that circle. That said, the reality is that these protocols are meant to be used, and therefore they escape the academic world and they enter into the world of engineering. And to be honest, the academic papers are less interesting to the engineers because you have to start talking about things other than just security. You have to start talking about things like usability and practicality and usefulness according to a particular domain. The other thing is protocols are not universal and ubiquitous in that they're useful for everything. The reality is a protocol is a tool, like a hammer or a screwdriver or any of these things. And as a consequence, not every tool is meant for every job. So you need to think about things like privacy, level of centralization, performance requirements, how resilient you want the protocol to be to failure, deployment scenarios, For example, is it run by a small group of people or a larger group of people? Are they geographically clustered, or is it all over the world? Are these nodes intermittent, or are these nodes online 24/7 and so forth? So these factors kind of drive which protocol is more meaningful. Now, our hope is that we can start having, as a community and in a space, a broader conversation about such things. Because what we've seen, unfortunately, is that there are financial incentives for people to make very bold claims about the things that they build and their engineering approaches. For example, they'll say things like 500,000 transactions per second, or they'll say things like you can move blocks around in 500 milliseconds or something like that. And unfortunately, that's probably not true in almost every scenario. And even if it is true, it would only be true for a very particular, very specialized type of deployment and a very specialized type of use. But in real life settings, especially when you're talking about cryptocurrencies, you would seldom see numbers like that or seldom see performance like that. And even if you did, you usually have to give up something very significant. So we will certainly make a bigger effort moving into the future to have a broader discussion about trade-offs and a broader discussion about utility and usefulness and about what security assumptions you're making and basically who are you putting in control when you launch these types of protocols. The other thing we're really keen to do moving into 2019 is to start layering protocols with new capabilities. In particular, there's a big discussion right now in the Bitcoin space about using things like Lightning, for example. And there's a lot of merit and a good idea in saying that if you hybridize a base protocol that is slow, highly secure, and very decentralized with much more performant federated protocols that can be used for certain use cases like, for example, microtransactions, or for connecting on federated actors like banks or financial institutions, it does make a lot of sense to think about that model because you kind of get the best of both worlds. Those who appreciate privacy, trustlessness, and decentralization have a fallback, and those who appreciate performance at any cost have an avenue to go through, and you can use the same underlying financial instrument for both. To this end, we started looking into second layer protocols that we think over the next year or two can gradually be pulled into Cardano. And this includes temporary protocols, so things that you do for a short period of time, like, for example, the Kaleidoscope and Royale research stream that we're doing out of Tokyo Tech, or for things like card games and eventually broader computations like decentralized exchange, to things like making our transaction system faster through things like payment channels. In particular, we're really interested to see if we can use trusted hardware for that. So that's going to be a big agenda moving into 2019, and it's something that we think is underappreciated right now, particularly in the smart contract space, and look for some of our foundational research there. The good news is Ouroboros is a tremendously good protocol for these layer 2 style solutions, and that maps, because of the slot leader design, very, very nicely into that architecture. And we think that there's some really cool things that can be done there that add a lot of value to the ecosystem as a whole. So overall, Cardano is coming along quite nicely. We're pretty happy with the workflows that we have. We're starting to see more consistency and reliability in the dates that come through. We're starting to see a lot less surprises. The code quality has gone up enormously, and the engineering quality has gone up enormously, and we've really found an easy way to work with a lot of partners. Many people don't know this, but IOHK is only one of many engineering companies that actually is working on Cardano. On the auditing side, there's FP Complete. On the development side, there's IOHK, Tweag, Well-Typed, Predictable Network Solutions, Cuvic, Allied Testing, and a few others here and there, usually small consultancies doing various little things. So each and every one of them has their role. They're all geographically dispersed, doing various interesting things. And it took quite a bit of time to figure out how to manage all of that and get predictability. Because if you have interdependencies, if one is delayed, it kind of delays everybody. So we've gotten better at thinking about how to handle that. So I'm really excited to see the second half of this year materialize, and I'm really excited to see 2019. I think that's going to be our year. And then we can get on to things like sharding and blockchain-based governance and so forth. As a final thing to mention, we're really interested in wallet diversity. So a little bit about that roadmap. At the moment, because the protocol is still going through flux, and there's still a lot of active research. It's counterproductive to have lots of competing implementations, because when you come finally to a solution, there's a huge coordination cost, so it dramatically slows down the ecosystem. But for the sake of resilience and decentralization, it is important that wallet diversity occur. So we're actively moving towards that, and the heart of wallet diversity is specification. So the first specification that we released was the wallet backend spec, and then you'll see specs for the core, for network, and for other components of the protocol, and these are implementation independent. So any developer with a reasonable set of skills should be able to take that, and in any programming language they so choose, hopefully one's chosen with wisdom, they should be able to build a wallet. So we have begun an effort to start constructing a parallel full node of Cardano in Rust. And you might notice that in our GitHub repo. So we're going to be scaling that effort up, and then our hope is to find a partner to maintain that Rust client after it gets to a reasonable level of maturity. Moving forward, it would be nice to also see wallets materialize in more exotic languages, perhaps Elixir, and more standard languages, for example, like TypeScript/JavaScript, for basically pedagogy and developer accessibility. This said, one of our hopes is in 2019 to start rolling out a Cardano improvement proposal process. So the heart of Cardano effectively are the specifications that Cardano implements, and then there would be a CIP-style process with some form of a steering committee or some form of blockchain-based governance to update those specifications in a very systematic way with a lot of community input. So there are some good ideas on how to do this. If one looks at the Linux Foundation and how the Hyperledger project is governed, there's quite a bit of merit in that structure. But it is sometimes bureaucratic and not as inclusive as it needs to be. So that's going to be one of our great challenges in 2019 as things become less technologically challenging and they go into more social challenges and coordination challenges and control challenges and so forth. But we're up for it, and we think we can bring something new to the space. Anyway, thank you so much for your passion and your enthusiasm and your excitement. It's been a very long ride, and we've certainly had a heck of a lot of fun. We're still having fun, and we're still doing interesting things. And it's nice to see Cardano start maturing as a product and really get a lot of interesting things. For example, like Ledger support should come with 1.4. We've already released paper wallets. Shortly after Ledger, we'll probably have something with multisig. So, we're really getting into that backbone and looking more and more like what people tend to expect when they think of a cryptocurrency. But the nice part is the core is very different in that it's much better built, it's much more secure, and it's constructed with peer review. The other thing is we've brought a lot of brilliant people along for the ride and made them care about our protocol. So it's really exciting to see them start coming up with even better ideas than the ones that we've seen in the space. The input selection policy in particular, it's something that probably should have been done a long time ago, but it's nice to see something like that developed out, and our hope is to bundle these things in papers. Okay, so that's everything from me. Thank you so much for listening, and until next time, guys, cheers.